Hey everyone, welcome back to part 3 of this video tutorial series on building video analysis apps with Bubble, Gemini, and AWS. In this video, we're going to look at how to take the Docker image that we built in the previous video and upload it to AWS so that we can use it for our Lambda function. So in order to do this, we need to cover what AWS ECR is, or Elastic Container Registry. This is just a way for us to upload Docker images to AWS and then use them in various ways. And we'll talk about briefly some of the different integrations that are available. If you're using ECR, there's all kinds of different services on AWS that will pull those images to deploy that code. And we'll have to know a little bit about AWS IAM, or Identity Access Management, which is how we give different permissions for functions and APIs and servers and that sort of thing to access different resources in our AWS accounts. And then lastly, we'll touch briefly on how you can access these Lambdas once they're deployed, but we won't actually do that in this video. We'll do that in the next video where we talk about building an API gateway so that we can expose our dispatch function. So what we'll do in this video is we will create a repository on ECR. We'll take our video parsing image that we created on our computer and tag that so that we can upload it to ECR. And then we'll create a Lambda function that uses this Docker image or this ECR image as the code that's actually running when we invoke it. And then the next thing we'll do is we'll create a small function in front of that, which is this dispatch function here. And this dispatch Lambda function is just a small piece of code that will start the video parsing process. It will kick off our other Lambda function, but it will do it in the background in such a way that it doesn't block the UI or the app that the user is calling it from. So basically the user will click a button in Bubble and that will cause this dispatch function to fire. And the dispatch function will send a message back to Bubble immediately, but what it's actually being used for is to trigger this video parsing Lambda. So we will upload our local Docker image for this video parser Lambda, and then we'll just take some code and paste it into this dispatch function for a second Lambda, which is only a couple of lines of code. And then once we have those two Lambda functions up and functioning, that will be the end of this piece of the tutorial. And before we get into the tutorial with ECR and the rest of it, I want to just mention that I've made a few changes to the code in the video processing image. And I've uploaded the code as it currently stands to GitHub, which you can access at this URL here. So you can just pull this code down and use it if you want. But in the video processor code, in the Lambda function itself, I've made a few modifications. So for example, I had a note on the previous video that we didn't actually need a separate download file function because the CV2 function we were using to parse the video would take a URL. And a few other fixes that needed to be made. So if you are looking for reference code, this is a better reference than the video 2 code. And we're also going to be revisiting this code in the next tutorial to look at how we actually pass our files to Bubble. So for example, we have two new functions here, create content parts and send content parts to Bubble. So we're going to circle back to this code after we've finished with ECR to look at how to modify this Lambda function to actually send our data back to Bubble, but we don't need to go into that just yet. So with that out of the way, let's get back to using ECR, and we'll come back to this stuff later in the tutorial. Okay, so the first thing we'll do is just get a broad overview of what ECR is and how to use it. So like I mentioned a second ago, ECR is the Elastic Container Registry, and this is just a place to upload and host your Docker images so that you can deploy them using various other AWS services. So in our case, we're using ECR with Lambda. So we're going to upload our image to ECR, and when we deploy our Lambda, it will pull the code down from ECR. But there are several other services on AWS that have the same basic idea. So for example, with Batch, you can run long-running processing jobs that might take an hour or more. And if you package up your code as a Docker image and upload it to ECR, Batch can pull that code and run it. So understanding how ECR works is useful for integrating with a bunch of different pieces of AWS as a cloud provider. So let's look at what ECR looks like in AWS. This is one of the landing pages for ECR. So if you come to ECR, you might see this, which is kind of the Get Started page. If you click this Get Started button here, it will take you to the wizard to create a new repository, and we'll do this later. But for now, this is what it will look like if you already have some repositories. And so it just has the name and the URI and so forth. And then if you click into one of these repositories, you'll see you have different images. So that Docker image we built before is going to end up here in a repository that we create. So I have one here called Video Parser for testing, but we'll create a new one for the sake of this demo. And so basically this latest points to one particular upload or one tagged version of the code that we're going to upload. So you can have, like I showed before, you can have different tags on the end of your images. So that's all this is. So there's not too much here to sort of be aware of. But the other side of things that kind of tripped me up a little bit is the Elastic Container Service. So the Elastic Container Registry is where we host our images, but the Elastic Container Service is sort of how we deploy those images in one particular use case. So for example, if you click here for ECS, Elastic Container Service, or EKS. This is Elastic Kubernetes Service, which is another service that integrates with ECR. These are two different ways basically of managing the containers that you have running for an app or an API or something. We're not going to use either of them in this case because we're integrating with Lambda, but I just wanted to point out that ECR and ECS, they're very tightly coupled. So if you want to use ECS, ECR is how you get your code ready for ECS. But ECR is sort of a broader product that supports a bunch of other services besides ECS. Okay, so I'm going to close this, and what we'll do next is go to the documentation for deploying Python Lambda container images. And we saw this before in the previous tutorial. So we'll come back down here, and where we left off is we created our image from the base image that AWS provides. We tested it locally by using curl. And where we're at now is deploying the image. So we're going to walk through these steps to create our repository and upload our code. Let me take this camera and move it out of the way. So the first thing we need to do is authenticate to ECR using Docker. So in our case, we'll do this step on the command line. And if you just copy this command and paste it into your terminal or PowerShell, what this will do is it will grab your credentials from your command line configuration when you downloaded AWS CLI. So this is running the command line interface for AWS. It will get your login password for whatever region you're running in. So if you're in US East 2, change this, or whatever other region. And then it's going to pipe that password to Docker. And then Docker is going to run its login command, and it's going to try to authenticate to ECR. So this piece here is your account level identifier for whatever your account ID is, and then like Docker ECR, and then whatever your region is that you're operating in, and then Amazon. So in short, we're just piping our AWS password to Docker, which will then try to log into ECR. So I'll take this command and I'll put it into a terminal and then adjust it based on my account ID. So we paste it in here, and then I just need to change this account ID, so I'll do that. And so in my case here, this is the demo account, and I'm using US East 1, so that doesn't have to change. I've just changed this number. And if I run this command, then I should get a message that says login succeeded. Okay, so now we've authenticated to ECR. I think these logins are valid for about 24 hours, depending on how you configure Docker, but by default, I think it's a day. So that's step one. Step two, it wants us to create a repository. So this is a place for us to hold our Docker images. And so if we run this command, it will create a hello world repository in our account. Now, let's look at this a little bit more carefully. So first of all, we say what the repository name is. So it's hello world. What's the region that we want to create it in? Now, if you put a different region here than you use to authenticate, it will fail and you would have to authenticate to that region as well. Then this option, image scanning configuration, this is whether AWS will automatically scan for vulnerabilities or issues in your image when you upload it. And then this image tag mutability, you can attach various tags to your images to keep them organized. And if it's mutable, it means you can change those tags after you've uploaded it. For our purposes, neither of those options are all that important. So I'm going to take them off just to simplify the command a little bit. And so now we have this repository hello world with the default settings. And so now if I run this command, I'll get the same output shown over here, of course, which is the details about the repository. So it gives us the Amazon resource name, the registry ID, which is just the same as your account ID, and some other stuff here. So now if we come back to ECR and refresh our repositories list, we should see this new Hello World repository. And if you click on it, there won't be anything in there yet. So the repository is just the way to hold your images. There's no actual code yet. And the next thing to do is get the code into the repository. So what I'm going to do is show you the other way that you can create a repository, which is just through the console here. If you click create repository here, it'll basically run the same command that we just ran, but if we just say hello to, you can set whether it's private or public. This is that tag immutability option that we saw in the command line. And then here's the scan option that we saw in the command line, and then encryption settings. So if I click create repository, it will just create a new one, hello to. So these are equivalent whether you do it from the command line or the console. I'm going to delete these now because we don't need them. And so now we'll go back to the documentation. So it says here in step 3, copy the repository URI. So in our case, that's this here. This is like the unique identifier of that particular repository. URI stands for Uniform Resource Identifier. It's just a standard term for unique identifiers for resources on the web. And the reason that we need this URI is we're going to tag our image with the URI of our repository. And basically what this will let us do is when we run docker push, which is the upload command, it will know where to send that image. So here's the general form of the tag command. So you say whatever your Docker image is, and then the tag that you need, and then you tell it where to go. So here it's saying the ECR repository URI, and then the tag. So you would take this command here, docker tag, whatever your image is, then your ECR repository URI, and the tag on the end. In our case, we also have to add sudo to the front of it. So in our case, our command would look like this. Now I just realized we forgot to create an actual repository to use. I have this video parser repository right here, and I've already uploaded an image to it, but we'll do this again for the sake of demonstration. So we'll close that out for a second. If we run, so let's actually create a repository to use. So we'll call it video parser demo. We run this, same thing, we should see the same output here. And if we refresh, now we have video parser demo down here. And so here's the repository URI. We'll copy this, come back to the documentation. And now here's the command sudo docker tag. Here's the name of the image. And just to show you that, if I run this, then here's our local repository, the local name of our image. And here's the tag demo. So now we want to tag that image with our repository URI, which looks like this. And so if we run this and then we relist our Docker images, we can see here now we have this repository. And if we look at the image ID, we can see it's the same image in both cases, but now one is pointing to our local repository of video parser and the other is pointing to the ECR repository. And so now that we've tagged it with that repository, we can push it up. So the command here is docker push and then whatever the repository name is. So we'll just copy that in a second. We'll say sudo docker. Actually, let's clear this out a little bit. We'll say sudo docker push and the repository URI. And so now if we run this push command, then we'll see it's now pushing each of the layers up to ECR. And so in our case, this image is several hundred megabytes, so it's going to take a little while. So I'll just pause the video here and come back when it's done uploading. Okay, so we've finished our push up to ECR. So now our image should be on AWS. So if we come back to Elastic Container Registry and we come into this video parser demo registry, let's make this a bit bigger so it's cleaner. Then we can see now we have a new image here, which was just pushed. Here's the size of it. And so now it's available to be used. So if we create a Lambda function, we can now reference this particular image. Now that's not quite our next step, because if we come back to the documentation, actually I can keep this large, we'll see here that you need to have an execution role for a function. So here it says create an execution role for the function if you don't already have one. What this means is when you deploy a Lambda function, you have to attach an execution role to it, which tells the function what it has access to, what it's allowed to do, and so forth. And so there are different ways that you can do that. We could, for example, create the execution role right now. And then when we create our Lambda function, we just attach it. That's one way. Another way you can do it is when you create a Lambda function, it will by default create a new execution role. And it won't give it the permissions it needs necessarily, but you can go modify that role to do whatever you need it to do. So before we actually create our Lambda function, we're going to take a couple minutes to look at how IAM works at a high level and how we can create these execution roles for our Lambda functions. So let's just look at this at a high level first. So IAM, or Identity Access Management, is sort of the permissions management system on AWS, and it's broken down into different concepts or entities. At a high level, there's this idea of roles. So we just talked about execution roles for the Lambda function. A role is like a group of permissions. So for example, we could have our execution role for our video processing function, and it has to have certain permissions. The way that we give it those permissions are through things called policies. And a policy is a specific grouping of permissions for specific resources. So for example, we might have a policy that allows us to access a certain S3 bucket. It might be able to call a particular Lambda function, and it may be able to read and write to a particular ECR repo, as an example. Another policy might allow us to read from all of our S3 buckets and talk to all of our Lambda functions. That wouldn't make a lot of sense in this case, but just as an example, those policies are groupings of different permissions. So in our case, we're going to need a role for our dispatch Lambda function and a role for each of our other two Lambda functions. So we'll end up with 3 different execution roles for these 3 different functions, and they may or may not have different permissions depending on what they need access to. I will say that you could create one Lambda execution role that has access to everything all your Lambda functions need and assign that role to all 3 Lambda functions. A Lambda function does not need its own unique role, but the reason to do it in 3 separate roles is to only give each Lambda function access to the resources it needs. So the least permissions model is pretty standard in security. So this idea of only assigning the permissions that are necessary for a particular resource to use is generally considered a best practice in security. So you don't want to give a Lambda access to all of your servers, all of your buckets, and so on, just in case that thing gets compromised or there's a bug in your code or whatever. So we'll take the more conservative approach and create an execution role for each Lambda function that only gives it access to the resources that it needs. So the reason I wanted to take a detour into IAM now instead of in a few minutes when we'll actually be looking at it is because here, if you run this command from the command line to create your Lambda function from the CLI, you need to already have a role created. So you would have had to do that in advance of creating your Lambda function. In our case, I'm going to create the Lambda function in the console. And when we do that, it gives us the option to create a new execution role. And for this Lambda function, for the video processor, it doesn't need access to any other AWS resources. By default, Lambda functions also get access to CloudWatch to store log events so that you can track and debug your Lambda functions, which we'll look at a little bit in a minute. But it doesn't need any particular permissions for accessing servers or S3 buckets or anything else like that. So we can just use the basic auto-generated execution role that Lambda will give us if we create it through the dashboard. So that's what we're going to do now. We're going to create a new Lambda function pointing at this image that we just created, and it will create the execution role for us. So let's do that. Okay, so we'll come back to the AWS console, and we'll come to Lambda. And here I've already created the 3 Lambda functions that we need for the tutorial just in test. So I'll create new ones for the sake of the video. So if you click over here, create function, it gives us 3 options up here at the top. Author from scratch, which we'll use for our dispatch function, but we're not using now. You can use a blueprint, which has a bunch of different stock or pre-built different types of Lambda functions. So some of these might fit your use case in various ways. You know, if you're interacting with batch or Cognito or something. In our case, we're going to be using the container image that we just uploaded to ECR. So here we can give it whatever name we want. So let's call it video processor demo. And then down here, it asks for the image URI. So you can paste it in here, or you can click browse images. And here we can pick from the repositories that we've created. Here's the one that we just created, the demo. And then here's the image that we uploaded to that repository. So we click that, click select image. And then if you expand this, this container image overrides. This is basically setting Docker commands or Docker options if they're different from the way that we built our image. But in our case, we were building our image for ECR, so everything is correct here. Then here you can set the architecture. You can leave this as it is. And then here's our permissions block. Down here, it's going to give us the option to create a new role with basic Lambda permissions. And this is what we want. We could use an existing role, like I said, if we created it before, or you can use these policy templates if some of these make sense for you. In our case, we want a new execution role. And then under advanced settings, we just have enable tags. You can turn this on if you want to use tags to organize or manage your resources. In our case, we don't need it. So we'll click create function. This will usually take a minute or two as it creates the new function. Then it will bring you to this Lambda dashboard. This is what you typically see when you're interacting with Lambda through the AWS console. Here it's still creating it. Up here we have an overview of our function. If you scroll down, you can see several other things. So this image is just telling us where the code is. In a later step in this tutorial, when we're creating our dispatch function, we'll actually see the code here, and we can write and redeploy the code here. In our case, it says our function code is deployed as a container image, so we can't actually see it here. All right, and now this has changed to successfully created it, so now it's ready to go. And it says we can test it with a test event, and we will do this in a minute, but before we do, I want to look briefly at the execution role. So if you come to configuration and then go to permissions here, here's the new execution role it created. And if you click on this, it'll open the IAM dashboard. And so here it is. This is the video processor demo role that it created for us. And if we scroll down, we can see this is the only policy that's attached to the execution role. So you can see that right now, all it allows us to do is create a log group, create log stream, put log events. So these are just logging functionality from CloudWatch. So let's go back to Lambda and test our function. Okay, so if we come back to the Lambda console, we can see here is our image overview. If we come to test, this is like the testing dashboard. Gives us the option to create a new event or edit a saved one if we have one. We can give it a name here. So let's just call it test 1. And this event sharing settings, unless you want to share this test event with other functions or other users, you can just leave this as private. And then here you can choose a different template. So here's the template we're using, the hello world template. But if you have a specific use case, you can pick a template out of here. Like for say, if you're using batch, you might want to use this template. In our case, we'll just use hello world. And then to figure out what we need to pass to this Lambda test event, which will be the parameters that are sent into our Lambda function when it runs, we can come back to the code. Here's the code on GitHub again. And down in our handler, we have these 4 variables at the top that are being pulled out of the event. We haven't covered the bubble URL or bubble video ID. These are part of the changes I made that I mentioned at the beginning of the video. These are for sending data back to our bubble app, which we'll talk about later. This count is for how many frames to handle. I mostly added this as a debugging parameter so that if this is passed, we just parse a subset of the frames, maybe 3 or 10 or something to speed up development. But the only one that we do need here is the video URL. So if we come back to our test event and we delete these 2 keys that we don't need, and we change key 1 to video URL, let's suppose I can make this a bit bigger. And then in the value, we put the URL that's pointing at the video that we uploaded that we were testing with, which is this here. Then now when we run our test event, it will try to pull down this video and parse it. Okay, so if I run this now, it's actually going to fail for a number of different reasons. Number one is it will time out because we haven't allotted enough time for this to run. This could take a minute or two, but by default, Lambda functions can only run for 3 seconds. So we have to change the timeout setting. Number two is it doesn't have enough memory. So it has 128 megabytes of RAM by default in Lambda, and that's not enough to handle this video. There are probably ways you could bring that down. But in testing, when it downloads and tries to load all of the video into memory and parse the frames, I was running out of memory with 128 megabytes. And then number three is we're not providing a Google API key. So we just need to set an environment variable on this function with our Google API key to upload the files. Otherwise, these three things will cause it to fail. So let's do the first two configuration changes over here. So we were in the test dashboard here. If you come to configuration, on the left, you'll see here this general configuration. So here we can set the timeout, we can set the memory. This ephemeral storage is how much basically the temp directory can store. In our case, the video is quite short. It's not very big. If you're doing huge videos for your application, you'll have to bump this up. It can be up to 10 gigabytes, I believe, but we can leave that alone. For our case, we'll change the memory to say 512 megabytes. As you increase the memory, you also increase the CPU available, so the number of processing cores that your Lambda function can use. And of course, this also increases your price. So you might want to play with this according to your use case to see what the optimal price and performance trade-off is. Here's that ephemeral storage. Yeah, you can store up to 10 gigs. We can leave that alone. And then lastly is our timeout. So I'll set this to 2 minutes, I think. Probably 1 minute is sufficient, but I'll set it to 2 and click save. And note that this is also where you might change your execution role if we create a new one, but we can leave this alone for now. We'll click save. So you now see it's updating the deployment up here. And now that's done. And so the other thing I mentioned that we need is an API key in our environment. So if we come to environment variables and we click edit, we can add a new one and we want to call it Google API key. And here is the API key we're using for testing. So we'll click save. So now when that Lambda function runs, it will have that API key in its environment. So it can pull it out and use it to upload to the file API. So now if we run this, we will get sort of halfway through our Lambda. We'll get the video pulled down, the frames extracted, and then uploaded to the Google File API. But it won't yet send our data back to Bubble because we haven't wired up that part. So what I'm going to do is run it, and we'll see the error message over in CloudWatch, just as an introduction to how to debug your Lambda functions. And then once we can see it's at least partially progressing, then we'll hook up our second Lambda function, which is the dispatch function, to be able to call this video processor Lambda. Okay, so let's go back to the testing dashboard here, and we don't need to change anything, so we save this. If we click test now, we can see up here that it's executing our function. It doesn't show us very much in here. But what you can do while this is running is if you come to monitor and then you look down here, there's some sort of aggregate metrics that aren't important for this particular run. But if your Lambda's been running and it's been invoked, say, thousands of times, then this is useful to sort of get an overview. But what we can do is click View CloudWatch Logs, and this will open up CloudWatch for this particular Lambda function. So if you've never used CloudWatch before, this is just like the logging functionality of AWS. And so this loads up. We can see here's our log groups. So you can have different log groups, which is just like a collection of different log streams. And then each log stream is like a collection of log events. So typically when you're doing this, you want to find the latest log stream, so the most recent events. If we click into this, then we can see here is the log, the output of our function. So there's probably too much debugging output in the function right now. It's outputting a timestamp and a file path and so forth just for debugging. Typically, you don't want to include this sort of debugging output when you're running in production. But the point is we can see it's now running. It's uploading the files to the Google File API. And at some point pretty soon, it's going to crash. And it actually crashed or finished because it timed out after 2 minutes. So it turns out 2 minutes is not long enough for this particular function. So I'm going to bump that up to say 5 minutes and then run it again. And what we should see is it crashes when it reaches the point where it tries to talk to Bubble. Okay, so the function has finished executing again, and now we get this error, invalid URL none. And if we expand this, we can see that this is where it's trying to send the data to Bubble, right here, send content parts to Bubble. So this is what we wanted, this is what we expected, that it would get to this point and fail. Technically, I could pass in a Bubble URL and a video ID, and this would complete as we want it to. But because we haven't covered that yet in the tutorial, I'll just leave this error as it is for right now, and we'll hop over to implementing the second Lambda function. So now we can go over and create our dispatch function, which will actually be quite a lot easier than creating this video processor function. We basically don't need anything other than the stock Lambda runtime environment. And I'll show you what we have here for video dispatch already. So I'll quickly show you what the code and the permissions look like here on the dispatch function. Then we'll pop over to GitHub to see where it is in that repo. We'll grab that code and create a new function just to go through the process. And then we'll configure the permissions using the IAM role that I've already created. So I'll show you how to add the permissions to invoke the video processor function. So if we scroll down a bit here, we can see this code. You can see this a little more easily if you click this button here to expand this code editor window. But this is the whole function. There's not a whole lot going on. In the beginning, we're importing a couple packages, and then we have a couple lines and basically one function call. So I'll bring this up in GitHub because it's a bit easier to see. So under this repo, we've got this dispatch function directory, and we've got our Lambda function here. And so this is the same code that we saw over here. And all it's doing in the Lambda handler, note this is called Lambda handler. In our video processor, we just called it handler, which is what the doc suggested, but it's the same thing. What we're doing here is we're initializing a client to talk to Lambda. So that's what we're importing this for, this Boto3 package. This is to call our video processor Lambda in a minute. Our body here, we're just pulling out of the event body of the request. So when we make our request to our function, we're just pulling that out. The video URL, we're pulling out of the body. Then we're constructing this payload that has our parameters. So we're just passing the video URL through basically. Once we get back to fully integrating with Bubble, we'll have to update this payload to also take a video ID and a Bubble URL, but we'll leave that for now. And then lastly, we're just hard coding the name of the function that we created a minute ago, this video processor demo function. Now, what you probably want to do is either set this as an environment variable or an API parameter so that it's more flexible. But depending on your requirements, you may be able to just hard code it. In this case, this dispatch function will only ever call that video processor function. So we don't have to make it more flexible. So it's up to you depending on your requirements. And then the rest of the function is just this try except block. So what we do is we use the Lambda client that we instantiated up here to invoke our video processor function. So we give it the name of the function. The key thing here that I talked about in the first tutorial is this invocation type event. This is what allows us to trigger the event in the background without waiting for a request. And then finally, we're passing our payload, which is just the body of the request that we're passing over. So that's this here. And we feed it to json.dumps. So basically to stringify this dictionary. And if it completes successfully, we'll get this message invoke request sent back. This is json.dumps. This probably doesn't even need to be here. This is if you're composing a JSON message usually. This could be replaced with a straight string. But if there's an exception, then we return whatever the exception is as a string. And that's all the code for the dispatch function. So what you could do to create your own dispatch function is you take this code, copy it, come back to the Lambda console and go to your functions. And we click create function and we can just say author from scratch. This is the simpler path than the container image that I mentioned before. And we can say video dispatch demo. We select our runtime, Python 3.12. That's all we really have to do for right now. For the execution role, we're just going to let it create a role and then we'll edit that role in a minute. And then we click create function. Now, while this is spinning up, what I want to do is show you the existing IAM policy that we have on the function that I created before. So here's the first video dispatch I created. So if we come into this initial video dispatch function and we come to configuration and permissions, if we click on this view role, it'll bring up the role in IAM. And so here in the IAM dashboard, we can see here's the role that was created for that dispatch function. And then we have two different policies attached to that role. So this basic execution role we've already looked at. This just allows the function to interact with CloudWatch basically. But the key difference is here we have this inline policy, which we'll create in a second, which allows it to invoke this video processor demo function. So I'll show you how to create a policy like this in just a minute. But basically this is where you can find the permissions for your functions. Okay, so if we come back to our video dispatch, it's been deployed now and there's no code here. So we'll copy this and just paste in the code that we grabbed from GitHub, which is this, and you click deploy, and then it's ready to go basically. But if we try to invoke it, we'll get an error. So note that if you click test, you'll get this sort of pop-up dialog. It's the same stuff as if you click test over here. So something else I'll point out before we get to permissions is if we were to put in a body like this, and then something here, say this pointed to our video, this would actually fail because the Lambda code is looking for something called body in the event. So this is a little confusing at first, but if we go back to our code, as I mentioned, we have this line here that's pulling the body field out of the event. And then we're parsing that further to get the video URL. So in your test, if you have an event that looks like this, it will fail because it won't be able to find the body field. So if I run this, it'll say it's key error for body. So what you can do for testing is you can create a test event that looks like this. So it has a body field in the event JSON, and then whatever's in the body field is a JSON escaped string that would be what we had before. So like this is what we want for the actual body, is this dictionary, but we pass it like this. And the reason that we do this is when we actually create our API in front of our function, it's going to have a body field, which is part of the event. So the whole event will include a bunch of other things. It won't just be this video URL. So we have to have this additional field of body in the test event to mirror what it's going to look like when we deploy a proper API in front of this function. So I found this really confusing when I started building and testing with Lambda and API Gateway. So it's worth being aware of that if you want your internal event JSON to map onto what it would see in a real API deployment scenario, you probably want to do it in this way. Anyway, so now we should be able to invoke this function without the code for this function crashing, but it won't work because of that permissions issue I mentioned before. So if we click test again, then we get a 400 and we get an error occurred access denied exception. So this is what we would expect. So it says this video dispatch demo Lambda is not authorized to perform Lambda invoke function on this other resource, which is our video processor demo. So what we're going to do now is modify the IAM role that's attached to this function to include a policy that allows it to trigger that other function. Okay, so let's do that now quickly. I will show you two different ways you can do this. The simple way is to give it access, give this dispatch function access to all your Lambda functions. That's quick and easy, but it's not the most secure. So we'll do that first, but then the second option is to only give it access to the Lambda function that you want it to be able to invoke. So we'll do that second. So what we can do is come back to the configuration and permissions tab and open up our role. And so here's our role for that dispatch function, like we saw before with the earlier dispatch function. We can say add permissions here. We can either attach a policy or create one. So if we have already created a policy, or if there's a stock policy we want to use, we can just say attach. And here there's a AWS managed one that will allow us full access to our Lambda functions. It's called AWS Lambda full access. If we attach this, say add permissions, now we see we've got this additional policy attached to our Lambda function. If we now try to run it again, if we come back to our test dashboard, just want to show here, this might be a bit confusing. It's showing us that our execution succeeded in launching, which is sort of true, but it didn't succeed in invoking that other function. So as a request, it succeeded, but in terms of the code's goal, it didn't succeed. So this green background is a little bit confusing, but in any case, if we click test again, what we'll see now is it actually shows invoke request sent. So it did trigger the Lambda function for the video processor demo. And we could confirm that by going into CloudWatch and checking the video processor demo logs and see that it triggered. But instead of doing that, we're first going to do a more secure policy. So we come back to our IAM dashboard. Here's the two policies again. We're going to remove this Lambda full access. And then we're going to say add permissions and create inline policy. Now there's two different ways you can do this. You can do it visually or using JSON. Visual is like a wizard, a step-by-step. So we could say Lambda here, here's a service. The action that we want to allow would be write and invoke function. And then for the resources, we could say all, which would be similar to what we set before, or we can say specific and we can add an ARN. So our ARN, or our Amazon resource number, is the unique identifier for the function we want it to be able to invoke. So the region is US East 1. You can see it's composing down here, whatever we type in these two boxes. And then the function name is video processor demo. So if you come here, it looks like this, video processor demo. So we could paste that in here, and now we have this ARN. If we click add, then now this is what will be part of the policy that we're creating. So we can click next. We can give this policy a name. We could say invoke video processor demo and click create policy. And so now again, we should be able to invoke our dispatch function and have it complete successfully. So if we click test, we can see it's successful again. Now, one last tip, just in case you're doing a lot of this, is that visual editor sometimes helps, but so does this JSON. This is easier to put into a GitHub repo. It's also easier to modify, in my opinion. If you have text like this saved somewhere, and you say add permissions, create inline policy, you can click JSON, and you can just paste your policy in here. So this policy is what we just created through that visual editor. You could change the name, for example. And so again, this is just another way of modifying your policies or keeping track of them if you prefer to edit with text. So at this point, we now have our video dispatch function that can call our video processor function and trigger off the job in the background. So we have got, if we come back to our outline, we've got this deployed, we've got this deployed, and we've got this connection made. What we're going to do next is we're going to build an API gateway in front of our dispatch function so that we can call it. And then we're also going to modify the code in the video parser function itself to send our frames back to Bubble, as well as modifying a little bit of code in each of these functions to take the required parameters from Bubble so that we can get that data back out. So all of that will be coming in part 4, so stay tuned for that, and thanks for watching.